Mark Sivak is, in his own words, a triple husky, and I'll let him explain what that means. But he has a PhD from Northeastern in interdisciplinary engineering. His graduate work is in the biomedical mechatronics lab, is focused on the creation of robotic rehabilitation systems with interactive motivational experiences. He's taught in interactive media and game design since 1909.
What?
And this is a small screen. So we need larger type. So, and in 2038 he will no. That was a long sabbatical. He's currently a joint hire with the College of Engineering and the Department of Art and Design. And the capstone project he advised last year, the Squid, was a winner in the Entrepreneurial Potential, the RISE competition, which is about to happen again, I guess. Is it? Yeah. So with that, I want to add one thing to put his work in context, to say that as an engineer in the College of Arts, Media, and Design, he represents the tradition of Da Vinci. So he has a high bar to meet. But also I would say that he represents, in a sense, the sort of inventiveness and citizen designer of Benjamin Franklin, and the way he crossed over from the social requirements and needs of the day as an engineer and thinker and tinker and inventor. But more importantly, I think he represents a vision of Buckminster Fuller, who says, start with the universe when you go to design things. So in some ways, he represents an emerging area of experience design that Buckminster Fuller would call comprehensive anticipatory design science. Thanks, Mark.
All right, so I'm going to turn the microphone too. I'm glad somebody else did it before me. So this right here is a great image in the background here. This is actually a 3D printed chess set. And if you do Google searches for 3D printed chess sets, there's like 100 of them, and they're fantastic. This was a low-cost machine that made these. I didn't make it, but I think it's just a great image. So who exactly am I? After Nathan gave me a great introduction, let me tell you a little bit more about who I am. I am a triple husky. I started here in 2002 as a mechanical engineering undergraduate student. I decided to stay for my graduate work here in the biomedical mechatronics lab, like Nathan mentioned, and I got my master's in mechanical engineering. Then I got an NSF fellowship to continue and finish my PhD in interdisciplinary engineering, because I found the box of mechanical engineering was getting a little crowded, and I wanted to break out of that shell, and so I continued on with my studies going into interdisciplinary engineering. So I am a joint faculty with engineering. I see myself as a Reese's peanut butter cup. I'm a combination of chocolate and peanut butter, two things that are great alone but better together. I teach currently in the Gateway faculty over at engineering, which is their freshman faculty. I teach their freshman design courses. I've also taught in mechanical engineering, which again is more my background, as well as interactive media and games here. So what is it that I actually do? Here are some of my current research projects. So the first one, this is the Atlas. This was the focus of my PhD, was actually on the creation of this device here, which is a low-cost at-home system for rehabilitation for people post-stroke. And the goal of it was to try and make something that was bimanual, something that you had to use two hands to work with, because rehabilitation for particularly the hands for people post-stroke is very difficult. So most people just learn to brush their teeth with their unaffected side. But that's a big problem if you want to ask people to open a pickle jar. That requires two hands. And so I designed this system and built the entire thing, and as well as all the software, and that was part of my PhD. This will actually be at RISE tomorrow if you want to come and check it out and play with it. It's an ongoing project that continues today. The other one, here's the Squid. This was actually the first version of the Squid, which was now we're calling the Workout Intelligent Trainer. It was a system set up so that we could take EMG sensor data and look at symmetry and fatigue in people as they work out to try and increase the effectiveness of the exercises that they were doing. And so what we are trying to do now is we change it up to a Workout Intelligent Trainer. It continues on. It's going to be the focus of another student's PhD. And he's looking at how do we create a system so that we can essentially have a smart coach that will be able to tweak and modify what you're doing in order to increase the effectiveness in kind of a closed loop way. and that's fantastic. We're also looking at, we're finishing up a proposal right now where we're going to look at modifying this from looking at the muscles on the torso to the muscles on the lower extremities, and we're going to look at ways of trying to to prevent people from falling. So people that are at high risk for falling, we're going to look for ways to use the data, the signals being sent from their muscles to try and trigger and warn to see, okay, you know, they're getting fatigued, they may have a chance of falling. And so that's another great use of this project. It was hooked up to a smartphone using Wi-Fi. It was a great combination of technology. The project itself last year was an awesome collaboration between interactive media and mechanical engineering. It was a chocolate and peanut butter moment. So No 2 Knocks, this is another project I've been involved with Ann McDonald. It's a game to teach STEM subjects to middle school students. We give them a GPS unit and we allow them to take it around for a week or more, and we use their data, their personal data, what they've done personally traveling around, going to school, going to practices, and et cetera, friends' houses. And we take that and we put that in a context that they can use personally, that they can own in order to play a game. And what we're trying to do is add more weight to the data that they have, because the fascinating thing about middle school students is they're not old enough to drive. So most of their decisions on how they go places may not even be up to them. So what does that actually mean to them? How do we make it important to them? And so here's an image of us at one of our first play tests at a school in Brookline. That was actually, we were doing all paper tests at that point, but at this point now, we are moving on to all digital, and we are working on the first revision of the game. And then this is another great project called Shortfall, which is another game. It's meant to teach environmentally benign manufacturing to undergraduate engineering students, particularly mechanical and industrial engineers. The fascinating thing about this is I actually did an independent study in 2007 when I was finishing up my undergrad, where I made the first digital version of this. And then years later, after finishing all my graduate work, I was asked to be on a Tier 1 grant that was successful after this was successful with the big NSF grant, to come back in on the project and continue working on it. So I kind of fell out of the loop and came back into it with this project, but it's ongoing today, and we're planning to break it out to more universities to look at scope and scale, because for the most part the game is finished. But the great thing about this is we're looking at ways of bringing together students in the classroom to use their experiences and their understanding of competition and feedback in order to enhance the learning available to them that they can't get by just looking at slides on environmentally benign manufacturing. A lot of students go to sleep or glaze over pretty quickly, but if you put it in the context of something like this, we found that they really are interested in it, and they're interested in learning more about it, scavenging information on their own. So why am I actually here? What is the reason I wake up every morning besides the cup of coffee that I drink? Potential. One of the reasons why I really am very happy I'm here in the College of Arts, Media, and Design is that we have a very diverse college. And that means that we have both really diverse faculty for collaborations, but as we saw with the student presentations this morning, we have awesome students. We have some students that are self-directed, that know what they want to do, that do things outside of a lot of the boxes that are created in other colleges and other universities around the world. And so one of the great things I think that is unique to here, CAMD, is the possible potential between these two, both students and faculty. I also, for me, it's a great lesson in perspective, because I am a stranger in a strange land. I do have a PhD in engineering, and every now and again, I do a bit of culture shock, where I'm like, oh, well, you don't think like an engineer. I thought you would, because I am an engineer. And that's been really great for me in broadening my horizons, and also directing the way I feel about my research and what can be done with what we have available here. I also am really interested in technology. This is a low-cost 3D printer. We're currently building one in the biomedical mechatronics lab. Costs about $400 and could build things like that chess set I showed in the first page. I'm interested in looking at technology from both what can be done now and also what can be done in the future. Technology is moving incredibly fast, as you all know, so how can we harness that for both good and for better outcomes in life? And also I'm really interested in design, the design of devices, design of interactions, and design of experiences. So how does this all culminate and come together? So right now, in the spring 2013, Ann McDonald and I are teaching two courses. One, I'm teaching physical computing, which is a new course. It's been on the books for a while, but never offered in interactive media. Ann is teaching a class, environmental graphic design, and we have decided to have these classes meet at the same time. And so what we do in physical computing is we look at hardware and sensors, we look at software, we look at prototyping, we look at device design. We look at it as a way where data comes from, okay? And that's really what we're focused on. And if you look at environmental graphic design, we're looking at information design in an urban context, we're looking at wayfinding, we're looking at some exhibit design, we're looking at ways for people to use data that's been created. And so we got together once a week for the first 5 weeks, and we did some joint lecture topics where Anne lectured from the position of an environmental graphic designer. I lectured from the position of someone who's doing physical computing, but we covered the same topics. We covered what it's like to be in a human system. We covered the psychology of experiences. We covered audience and emotion. We covered empathy and community, and we covered data and sensors. And this was all great because the students got to see with complementary skill sets what it's like to kind of broaden their horizons and see more about where everything comes from outside of their boxes. So the joint project that we're trying to get together with these two classes is solutions that impact the quality of life. We're using data and information to enhance the quality of life, and we're looking at an urban context at different scales, from the apartment to the building to the block, and we're also looking at addressing problems holistically. So what's the bottom line? I consider myself to be a bridge to engineering. I really love doing interdisciplinary research. I'm really interested in the combination of technology and design, and I really love to look at interactions and experiences between people. Thank you.